So this video is designed to help you with an idea called combining like terms. On the board I have an example, 8x plus 9 plus 10, and as you look at that, what you're thinking is, are there anything that's alike? Is there anything that has the same kind of features? Is it numbers? Is it variables with the same exponent? Things like that. So as I look at this very simple example, I know that the 8x and the 9 are different, so I can't combine those. One has an x or a variable and the other doesn't. But the 9 and the 10 are the same because they're both just lone numbers. So 9 and 10 can be combined to make 19, and then the 8x just stays 8x because there's nothing to combine it with. So I can simplify this expression from 8x plus 9 plus 10 to 8x plus 19. Okay, another example like that, 7 plus 6x plus 9x plus 9. As you're looking at that, you notice that 6x and 9x are alike, and 7 and 9 are alike. So I can combine the 7 and the 9 and get 16, and the 6x and the 9x to get 15x. And this is how I'd write it like that, 16 plus 15x. Or some people prefer 15x plus 16, and I can write them in any order because of the associative and the commutative properties of addition. However, we tend to write the x first and then the number by itself. Now it gets a little bit trickier when we introduce subtraction into an expression, but if you remember that you can change any subtraction to an addition problem by what we call adding the opposite, it makes it a little bit easier. So I'm going to start with that. In this one it says 9 plus 3x plus 1 minus 2x. I'm going to rewrite that, leaving the addition alone, but changing the subtraction from a minus 2x to a plus negative 2x. And when we know that when we do that, it's going to remain the same value. So now as I look at that, it helps me remember when I'm combining things that are alike, that on my x's, I have 3 positive x's and 1 negative x. When I combine 3 positives and 2 negatives, I'm going to end up with 1 positive x left over. So I'm just going to write that right here. Now some people will write it 1x, and that's okay, but we don't really need the 1. And then I notice that I can combine the 1 and the 9 because they're the same. So I end up with x plus 10. 9 plus 1 makes 10. And again, I could write that 1x plus 10, but this is the preferred answer. Now, combining like terms comes in especially handy when you use the distributive property. Look at this example up here. It adds a layer of difficulty. We have 8 plus 7 times the quantity 7n minus 4. Now, if you remember, the first thing I want to do is I want to change the subtraction to an addition. So I rewrite the whole expression. 8 plus 7 times 7n plus negative 4. Okay? Now, once I have that written, I think I can't really combine things until I simplify it. And to simplify it, I use the distributive property. So I take this 7 that's outside the parentheses. This 8, by the way, is not attached to that parentheses, so I'm only going to distribute the 7. The 7 distributes to the 7n, so I get 49n. 7 times 7n is 49n. And then I get 7 times a negative 4. So I'm going to have a plus negative 28. 7 times negative 4 is negative 28. And then don't forget I have this lone 8 that's still out there by itself. Now when I look at that simplified, it's a little bit easier to see. I can combine a negative 28 and a positive 8 because they don't have variables. They're the same. They're what we call like terms. So negative 28 and a positive 8 is going to be a negative 20. And then I still have this 49n that's all by itself. So I'm going to bring it down. So I'm going to bring it down. And I can't combine these last terms because they're different. They're not like terms. And again, I can rewrite this 49n minus 20 or 49n plus negative 20. And those are all equivalent expressions that mean the same thing. If I were to pick one of these that's most preferred, this one is the most traditional and most efficient. So this next example will illustrate the importance of changing it to addition before we start. There's two subtractions in this problem. One is out here in front of the number that's being distributed. It's 3 minus 3 times the quantity x minus 2. The other subtraction is right here in the parentheses. As I change them both, I think you'll see that it was helpful to change especially this one to addition. So that as I do that, I rewrite it 3 plus negative 3 times the quantity x plus negative 2. Okay? And then I'm going to want to use the distributive property to simplify it. So I can simplify this part right here. Negative 3 times x is a negative 3x. Notice how it's a negative 3 now, not just a 3. And that's where students end up making mistakes. So be careful there. And then a negative 3 times a negative 2. Another area to be careful of. A negative times a negative is a positive. So here we get a positive 6. And don't forget, we have that 3 that's out in front. And now as we look for things that are alike, I notice that a 3 and a 6 are alike. So 3 plus 6 makes 9. And I also notice that a negative 3x is out here by itself. So I combine those together, negative 3x plus 9. And that's as close as I can get them. I can't combine them any further because they're not like terms. So this idea gets really fun when you have more than one set of parentheses and you have to distribute and then combine like terms a couple different times. So in this example, I see 3 times the quantity y plus 5 plus 7 times the quantity y minus 5. And of course you're probably remembering that we're going to change this to y plus negative 5 before we do anything else. So notice nothing else in the problem changes yet. And then as I go through this problem, I want to distribute the 3 that's outside the parentheses to the y, and that's going to give me 3y. Then I'm going to distribute that 3 to the 5, and that's going to give me 15. But the fun's not over. We also have another parenthesis over here. So I need to distribute the 7 to the y, and then the 7 to the now negative 5, so we get plus negative 35. Then we start looking for things that are alike. So I notice right away I've got 7y and 3y. If I combine those together because they're like terms, I get 10y's. 3y's plus 7y makes 10y. And then we get 15 plus negative 35. And if I have $15 but I spend $35, I believe I'd be down 20. So I have minus 20. So 10y minus 20 is my final answer. But of course, you can still write that 10y plus negative 20. Oh my God.